Hello, this is Dr. Christy Patton-Lukes, a chemical engineering professor at Missouri S&T. In this video lesson, we're going to be looking at green engineering or sustainability issues. So we want to look at ways that we can design our process to minimize pollution and introduce the concepts of sustainability. Now, there are a lot of environmental laws that tell us what we have to do. The earliest of these were 1970 was the Occupational Safety and Health Act and the Clean Air Act. And those began the system of guidance that we've had. And these change now every year. If you look at this, we've got the Clean Water Act in 72, rules on insecticides and fungicides and toxic substances, and just so many different rules. You'll probably, at the company you work for, have somebody who is responsible for keeping up with all of these rules. And they change all the time. The Pollution Prevention Act of 1990 is probably a good one to really focus on. It's kind of got a lot of key concepts that are used for all sorts of things. The standards may have changed, but the concepts are pretty much established there. What you have is a waste management hierarchy. And so the best thing to do is to reduce the amount of waste at the source, or recycle it in the process, or at least maybe on your site. If you can't do that, send it to another facility that could recycle it. If not, then go to waste treatment or some sort of secure disposal system. The places where they bury things for 1,000,000 years. Our last resort should be releasing to the environment. Now, to determine what's going to happen to some chemical that we release to the environment, whether it's accidentally or intentionally, we need to think about the physical properties. So basically, it's what's the melting point or boiling point. In other words, is it going to be a solid, liquid, or vapor in the environment? What's the vapor pressure? What's the Henry's law constant? What's its partition coefficient in the octanol water partition? Will it dissolve in the organic phase or in the aqueous phase? The soil absorption coefficient, bioconcentration factors. So these are all the things that you need to know to be able to analyze the ultimate fate of your material. Now, some of this is in the safety data sheet, not all of it. Additionally, there are a lot of other green chemistry issues. The people who were doing the 2020 AICHE National Design Problem this year, it is a problem where they are being asked to do a process intensification. So that's something that is a big topic. We'll have an elective on that offered this next academic year. But you could look at alternative feedstocks that are not going to deplete renewable resources, so biofuels fall into that category. Solvents that we use, maybe there are some solvents that are less hazardous and non-toxic that would be a better choice. Or maybe, although one synthesis pathway may be the most economical, but maybe it's not the best because of the hazardous intermediates. The final issue that we want to talk about is various forms of life cycle analysis. Now, those who took my little one-credit class this semester have done an intensive look at this, but basically this is a cradle-to-grave analysis where we look at from the very, very start to the very, very end what happens to our materials. So we want to look at our inventory analysis, all the material and energy inputs and outputs over the entire life of the process. And then what are the impacts of that? So what are the environmental consequences of inventory analysis? And then how could we improve this process or product? So we want to think about the raw material acquisition. So here I have our raw material acquisition is an oil pump, okay? Because petroleum is the basis of the plastic used in this milk bottle here. And so we want to think about then how we get our raw materials, how we actually manufacture the material and the product. So make the plastic that then goes into the bottle, or yeah, bottle is good. And then how do we use the product, and can we reuse it? So here, reuse it as a bird feeder. And then ultimately, what's going to be the ultimate fate of this? How will we dispose of it? And sadly, for many of our plastics, we put them into a dump. So we want to think about this in ways that we could improve upon the entire life cycle analysis. So these are some things to think about when you're writing up your final report. It would be good if you addressed some of these concepts and issues, not asking you to solve the problems, just to think about them and begin considering whether or not there's something fairly straightforward maybe that you could have done differently to make a more environmental choice. So this concludes our lessons for Design 1. I look forward to reading your final reports and seeing what you do in our Design 2 course. Thank you very much for your time.